Hi, in this lesson, we'll explore the MLFlow experiments and how we can promote one of the or the best model to be or the best experiment to be a model. We're still here in this experimentation. If you lost this page or if you go another way, you can go to it from experiments. You see here experiments. You're still in the machine learning persona. You go to experiment right there. You see your experiment here. So we've done one experiment, which is right there to automatic machine learning. You click and you come back to the same view here. So it's an automatic machine learning survive train solver. This is the name of the experiment. And this is all the notebooks or all the experiments that was performed in order to get to the best model. One thing you can do here from MLflow perspective is you can add more columns. If you want to see something that you wanted to compare or something you wanted to explore further, you can do it here. Training F1 score. This is like how, like, if you want to compare like the training F1 score and the test F1 score or the evaluation F1 score, validation F1 score, you can look at this and compare it in here. We can add even more column if you like, but this is like a view where you compare things. One more interesting thing you can do is you can actually compare the model. So let's pick this one. So this is all logistic regression. We can pick all the logistic regression one. If you want to do a comparison across all logistic regression, you can select these ones here and all the ones that you are interested to compare. And you'll see once you do this selection, you'll see maybe something appear here at the top. It's called compare. So I'm going to click compare. And in compare, you're going to see a comparison between the machine learning models that you have chosen in order to compare against some values. So this is the the parameters that you have chosen here. I think for the machine learning, I want to compare the L1 value, so L1 ratio as well. I wanted to compare, you can choose whatever value from the machine learning model that you selected. You can select whatever values here you wanted to do, and then also you can compare it against test accuracy score, maybe test F1 score. Yes, so test F1 score. Maybe we wanted to compare also against training F1 score and validation F1 score, right? So ideally we wanted to get the best validation F1 score. So we can do selection here. So you can see validation F1 score has came from this path on this column. So preprocessor, this value, and classifier C20 was like a value that it chooses. You can look at this is remember, just regression have a few parameters to compare, so not much here to look at. Maybe like classifier C and so on. But if it's something else, let's see if we try to compare like decision trees, for example. Now, decision trees has a lot of parameters, and when you choose the comparison, you'll see that maybe there is a lot of things that you can, if you change here, let's select decision tree, this one here. This is a decision tree, another decision tree here, right there, another decision trees, and maybe decision tree as well here. So basically, MLflow allows you to do a comparison of the machine learning model. And as a data scientist, this is one of the things you would always do. You wanted to compare what are the we call this hyperparameters. What are the best hyperparameters that you would choose in order to compare? So I wanted to compare this against the validation set F1 score, because this is the one I'm interested on, right? Also, you can amend this one. You can add all the values that you are interested on. You can add everything that makes sense for your comparison and for order for you to look at and make sense of the numbers, right? And so I'm just did my thing here. So this is the best F1 score. You can see the path. This is really important. There is also other kind of plots here if you wanted to take a look. and you know, change if you wanted to compare against, I don't know, like alpha or against weight, whatever the number that you choose. In other words, Databricks will give you, MLflow will give you a good set of comparison tools in order to make your life easier when you look at different parameters. You can see it even as a tabular format, and as everything that makes it easy for you. There's a box plot, there's a contour if you wanted to like to look at the contour. So Databricks, like, we give you this feature, right? Now if you go back, there is actually give it a try. So there is new enhanced comparison experience from Databricks, and this is one good thing about the Databricks platform, is it gives you a lot of feature instantly. Whenever you choose something you wanted to compare, Databricks will give you a comparison of this thing, and it gives you even further enhancement to make sure you enjoy the best experience in the platform. So this is the best model. So let's go back to the best model. So we see the best model in here, in Databricks. We got to the best model, right? Let's say, I think it's going to be if we sort it by validation F1 score, this is the top model. If you click on this best model, now you've got this description of the best model. You can add, everything that you wanted to do, maybe description tags and everything. But if you scroll down a little bit, this is what we call the model artifacts. Now, what is the model artifact? So model artifacts is pretty much everything that Databricks needed in order to produce this accuracy level for you, to make this run happen. Why is this important? Because one of the biggest problems with machine learning is what we call reproducibility. A lot of time, and it happens quite often, where you look at the machine learning model, you run the machine learning model, you configure some parameter, you run it, and you got, I don't know, 90% F1 score. Now you leave the data 2 days, 3 days, and then you go back to your model and you run it again without changing anything, and you get like 85% score. So what happened? Why am I getting different scores even though I changed nothing? This could be mainly for different reason. It could be data has changed in the middle. It could be something changed in the version of the libraries that you're using to train the model. It could be someone has changed something on the model itself, the way they impute the data, the way they normalize the categorical feature. This could be so many things that could have happened, so it doesn't reproduce the same accuracy that you've got before. So in order to avoid this problem, what MLflow inside Databricks does, it record every single aspect of your trial that could affect if it has a changed accuracy. If it could affect the accuracy if it changes. So it records things like, this is the ML model itself, like record the model, a description of the model and the parameters, and all these things. It record the Conda environment, like what kind of platform version, even the version number of the tools that were used to produce the experience. So MLflow 2.1, category encoder 2.5, Cloud Beckle 2.0, Databricks AutoML runtime 0.24. Yeah, like it records everything. So when you run this model, you're guaranteed to get the data, the accuracy level that you wanted. If someone added a new column, we're not going to take it into consideration in this run. Maybe a new version will take it, but this run consider only this column. So again, we keep the data and maybe a signature of this data by recording the first few rows and first row. We give you the Beckle files if you want to deploy this model somewhere else. Python environment as well, bib install, setup tools, wheel files, requirements, the generated confusion metrics, the estimator HTML, and this is like a nice like pipeline of actually every single step that was done during the model training, like which transformer we use. By looking through it, we did one hot encoder here for these columns, and we did I don't know, standard scaler for some columns. We did, you can see, I get a description of everything that was done for this experiment. and the left curve here, and the thing, the precision, and the ROC, training confusion. So basically Databricks have recorded everything that makes this run. We call it the model run, right? So we call this model run, one run of the model, reproducible. This is what you want to when you get. Now, if you look at the model itself in here, you'll see that this model is now, you can be registered. And registering a model is something that you would use for inferring the model. So this is something we're going to discuss in the next lesson. So see you then.